Hello everyone, my name is Gaurang Gupta and today we will be doing another machine learning project which is credit card fraud detection. In this we have to check whether the credit card transaction is a fraud transaction or it is a valid transaction. Here we will be having some parameters and this is the parameter class parameter which we have to detect as an output. So here it is given 1 is for fraudulent transaction and 0 otherwise. Now, one thing you have to note in this dataset is this is a highly unbalanced dataset. Here they have given us, so the class imbalance ratio is very high. So the confusion matrix accuracy, which we generally do in classification problems, it is not going to be meaningful until we make the data balanced. And we are going to do that in the code. Here you can also see they have given us the PCA transformation of the data. Why? Just to prevent the credit card information of the users. See V1 to V28. So I have already told you that it is a classification problem. Now let's move on to code. So first we will import all the necessary libraries. Let me start the kernel. So import OS, import NumPy as NP, import pandas as PD from sklearn.preprocessing, import standard scaler and label encoder. Then from sklearn.model selection, import train test split and grid search cv from sklearn.svm, import svc from sklearn.metrics, import accuracy score and confusion matrix. Then from mlextend.plotting, import plot confusion matrix. Then import matplotlib.pyplot as plt. Then import cbon as sns from imblearn.oversampling, import SMOTE. Then from sklearn.linear model, import logistic regression from sklearn.ensemble, import random forest classifier from sklearn.tree, import decision tree classifier from sklearn.neighbors, import kneighbors classifier, import xgboost as xgb from sklearn.ensemble, import adaboost classifier from sklearn.gaussian process, import gaussian process classifier from sklearn.gaussian process dot kernels, import gaussian no import rbf. Then from sklearn.neural network, import mlp classifier. So now let's run it. The code is executing. The code is executed properly. Now let's move on to next section, which is uploading the data. For this, first we will use a path variable, which will be an empty string for now. Then for dir name, comma underscore, comma file names in os.walk slash kaggle slash input. Then for file name in file names, path will be equal to os.path.join, not geno, join dir name, comma file name. This approach is working because we are sure that there is only one file in the dataset. This approach will not work if you have multiple files. For that, you have to declare this path as a list. So keep that in mind. Run it, and now we have our path variable. Then data will be equal to pd.readcsv path. Then columns will be list data.columns. It is executed, but no worries. Then print the columns and then data.head. Run it, and now we are going to see the columns and the first five rows of our data set. You can see we have time, we have a v1 to v28, amount, and class. So this class variable is our output. Now let's move on to next section, which is data pre-processing. For this, first we will declare the variable std, which will be standard scalar. Then data will be equal to std.fit transform data. Then data will be converted into a pandas data frame by using pd.dataframe, then data.head. Now, when the code will execute, you can see that we have lost all the column names. There is no column name like v1, v28, amount, title, time, class, etc. These are replaced with indexes. You can work with this data, but it is kind of difficult because if you have to pinpoint certain variable or certain column, you kind of will be feeling some difficulty because indexes and these are not same. Like first variable is actually time variable, so you can get confused. To avoid this confusion, we are going to rename it. So for renaming, we are going to use first the count variable, which will be set to 0 initially. Then for call in columns data dot call dot rename columns will be equal to cnt call, and in place will be true, then cnt plus equal to 1. Then lb equal to label encoder data class will be equal to lb.fit transform data class, then print lb.classes, and then data.head. Run it, and now you can see we have replaced the indexes with the column names. And I have also changed this class variable into an int, or you can say in 0 and 1, because the initial values were these. So these values occurred because we scaled the data. If you are separating this column, this class column, let me show you this class column here before scaling, you don't need to run this label encoder process, but I thought it will be easier to show you that way. So it is totally your choice. Now let's move on to next section, which is data visualization. Now for this, first we will see the d types of all the columns. So run it, and now we have data types of all the columns. You can see I said that I'm changing the class variables data type into int64. See, here it is showing. Then we are going to use data.describe to see description of different columns. Data.describe. So run it, and here you can see we have count, mean, standard deviation, maximum, etc. Remember that this is the parameters like standard deviation, minimum, maximum of scaled data, not the actual data. I'm repeating this for some videos, but this point is very important, so keep that in mind. Now let's plot the heat map of this data. So plt.figure, fig size will be 25 comma 15. You can change the size. I got the size by trial and error, so there is no hard and fast rule in that. sns.heatmap data.core anot will be false, then plt, not ptl, plt dot show. Run it, and now we will be getting this. We got this, which is our heat map. So here you can see most of the variables are kind of equally related to each other. Or if we are seeing this class variable, you can see most of the variables are not related as much to the class variable, or if some variables are negatively correlated. So you can see that, and you can say that we need to remove some variables so that our model is easy and takes less time to train. But again, you can use all the parameters. Then we will plot the hist plot for every column. So fig comma axis will be plt dot subplots 8 comma 4, not 88, 8 comma 4. Fig size will be 80 comma 150. Then axis will be axis dot revel. Then for call comma axis for uh, in zip columns comma axis plot equal to sns dot hist plot data call kde will be true, stat will be density, and axis will be axis. Then plot dot set x label will be call comma font size will be 35, font size will be 35. Then plot dot set y label density density font size will be 35. Then plt dot show. Run it. So now our code is executed. Here you can see we have his plots for every column. So here we have the class column. You can see that we have almost all the values of a particular class. For the second class, which is the one, we have close to none values. This is a very bad data set in case of if we are using it for classification as it is. We are not applying any class inequality removal, because what happens is that in these cases, let's imagine we have 100 entries and 99 of them are of particular class. So even if I don't train any model and I just say that predict every class as a 0, you will see that it will give 99% accuracy. Why? Because there are more number of zeros than ones. So how it will work? This is not a good classification dataset if we are using it without class inequalities. Now we will remove this class inequality and make the classes equal. There are many methods. I'm using a SMOTE method. You can use any other method. So for this, y will be equal to data class, then x will be data dot drop class, and axis will be 1. Then SMOTE will be SMOTE, then x SMOTE, y SMOTE will be SMOTE dot fit resample x comma y. Now print original original dataset sample, dataset shape, not dataset sample, dataset shape. Y dot shape, print resample dataset shape. Y SMOTE dot shape. Ones will be 0, zeros will be 0. Then for I in Y SMOTE, if I is equal to 1, then ones plus equal to 1, else zeros plus equal to 1. Then print ones comma zeros. Run it. Here you can see the original dataset has 284807 rows, or you can say that much entries, and in resample dataset we have more entries, and the column, or you can say the classes, are now equal. 0 and 1 are both equal classes. Now this is a good dataset for training our models. Now let's move on to the next section, which is training different models. For this, first we are going to get the training and testing data. So xtrain, xtest, ytrain, ytest will not test, will be train, test, split, xsmote, ysmote, comma, test size will be 0.2 and random state will be 0. Then we define an array models, which will be a multidimensional array and contain a model name and the model itself. So support vector, then logistic regression, logistic, then random forest classifier, n estimators will be 7, and random forest decision tree classifier max depth will be 7, decision tree. Then we will have k neighbors classifier. N neighbors will be 7, neighbors will be 7, and k neighbors classifier. Then then xgb xgb dot xgb classifier objective will be binary, logistic, and random state will be 42. You can pick any random state will be 42, and the boost, then ada boost classifier, and estimators will be 25, and ada boost classifier. Then mlp classifier, random state will be 1, and max iterations will be 300. 309, 300. Then MLP classifier. Then for I in models, name will be I1, model will be I0. Then we will print the name, model.fit x train, comma y train. Then ypred will be model.predict x test, print accuracy score y test ypred into 100. Then CNF will be confusion matrix y test ypred. Then fig comma ax will be plot confusion matrix. Confmat will be CNF, then plt dot show, and then not एक or show, normal show, then print a new line character. Done it. So now the code is executed. This code will take time because the data set is very large. So we have the accuracy and the confusion matrix of each model. You can see support vector is giving 98.1%, logistic 94.9, random forest is performing really well 99.98, decision tree 97.17, k nearest neighbor is also good 99.87, XGBoost 97.07, AdaBoost 95%, MLP 99.96. So we can say that random forest here is best performing. But as you can see, random forest has 99.98 and this MLP classifier. Let me show you. This MLP classifier is 99.96. They both are really close in terms of accuracy. So you can use either one of those. I will prefer random forest because it is showing higher accuracy. That's one of the reason. And second reason is MLP classifier takes a lot of time to train. And we have a bigger data set. That's why it is giving that good accuracy because it is a neural network. Let me show you here. It is a neural network model, so neural networks need a lot of data. So if that lot of data is giving you better accuracy, only then go for MLP classifier. If random forest is giving better accuracy, go with random forest because it will also help you to give an easy logic, because when you are building or explaining someone the logic of your code, it will be very easy to explain random forest regressor or classifier rather than any other model. So now our code is executed and we have completed the coding. That's all for this video. Thank you for watching the video. If you like this video, do like, share and subscribe to my channel. And if you have any other suggestions, doubts or anything you want to say, do comment in the comment section. I would be very happy to answer. So thank you very much for watching the video. Thank you.